I'm gonna start recording. Okay, this is recording. Okay. So let me share my screen. So are these questions from your exam or something like, or is it like a midterm or what was it?
They're just past paper questions that I looked up.
So you just kind of attempted these questions for practice?
Yeah.
Okay. Hmm. Can you see this screen? Just let me know if you can.
Yeah, I can see it.
Okay. So this is like a simple forces questions, and I see you've done the question number one, part A, 1 and 2 correctly. Like you've marked W and you've marked T in the right way. But the thing is that the total now let's come to part 3. Let's see, let's suppose that this point is the plane, and I'm just gonna mark every force that you've marked already. So this is the weight, and this is the force that is being generated by the plane itself. You've marked this T. Okay. So these two are the forces that you've already marked. उसके बाद no. Okay. Now let's start marking forces that are working opposite to these forces as reactions from the runway. Okay. So there, for the weight, there will be an opposite force reacting opposite in direction from the weight, the normal reaction force. Is that correct?
Yeah.
And there will be a force that will be applied in the reaction of the force T. Let's call this T prime, because we know that the jet is not yet moving.
Okay. Yeah.
Yeah, is it like clear?
Yeah. So
Okay.
if the jet was moving, would that not be there? Or
Yeah, so
would it be
that would be
friction?
so that would mean that there's an acceleration in the direction of T, but it's actually says that the jet is not yet moving, which means that the jet is stationary and it has zero acceleration. Zero acceleration, which means zero resultant force. So kind of everything on the horizontal plane cancels out each other. So T and T prime are working against each other, and normal force and the weight are working against each other in the vertical plane. So everything cancels out everything, and we have zero resultant force, hence zero acceleration. So we can say that the jet is not yet moving because of this. Okay,
Okay.
moving on. Now, the point I said when I started the lesson that the point is a plane. That plane is represented by a point, and every force that I have drawn using the orange pen is basically the force that you've already marked. So the weight was downward towards the center of the circle Earth, and T was in the horizontal plane from right to left. Now the reaction forces are all acting towards from which are acting toward from the runway to the plane are marked in red. Are these forces clear? Are these two forces clear? The normal force and the T prime that are
Yeah.
marked. So if I draw them separately, so this is normal and this is the T prime force. So these two forces are now are acting from the runway to the plane. Now, but we have to only mark these two forces as one force. So the resultant force of this force, the normal reaction force, and the T prime force. So the resultant of these two forces will be actually the force F, which is asked basically in the question. F is what? The resultant of the normal reaction force and the T prime reaction force. Okay,
Yeah.
is
Yep.
it clear?
Yeah.
So we'll just use any method that you like from the, either we can use the method of triangle addition or parallelogram addition. I'll just use parallelogram addition. So this is uh, this and then this and this is the force F. Okay,
Yeah.
so now uh, so this was the point plane and you marked W correctly and T correctly, and we found that F is actually in this direction. Okay, is the
Yeah.
is this point clear?
Yeah, it's clear.
So you have this question open in front of you.
Yeah, I was writing it. Yeah.
No, yeah, just I'm asking for the worksheet that I got. Do you have the worksheet in front of you?
Yeah.
Okay. All right. So moving on to the part B. Part B, you seem to have done correctly. I'll just go over it once. Part B. Part B, part one is calculate the minimum distance the jet travels from the rest to the point where it takes off. So now we can say that um, so part B, part one, you need to find the distance. So there are like some the formula that is mostly used, the formulas that are used for the linear motion are v squared is equals to u squared plus 2as, and s is equals to ut. S is equals to ut plus half at squared So this is the formula for distance, and this is the formula for distance, where this is S is the distance here. But actually, we will be using this formula only because this formula actually has a relation of distance with time as well, and we don't have any data for time. So the best equation that seems right now is this equation: v square is equals to u squared plus 2as. Okay. Now let's see what do we have here. V square is equals to u square plus 2as. V is already given, so it says in the question that the speed that is needed by the jet to take off is 56 meter per second. And the initial speed of the jet was actually 0 meter per second, given that the plane was actually stationary. S is what we are looking for. Now, you found A using the correct method, which is dividing the force by the mass of the plane. So F is equals to mass times acceleration. You've done correctly using this relation, and you've said that A is acceleration is actually equals to force divided by the mass. And force was given to be, I'll just mark this down, to be 28 kilonewtons, and the mass of the jet was actually 6,200 kilograms. So you use this to find A. Let me see, what was the value that you got? You got the value 4.5, and then you use it to find this. You used it to find 350 meters. Yes. Now, this was part B, part one. This was easy. This was the easier part. You solved this correctly, shabash. Now moving on to part B2. Is this B1 clear?
Yeah, B1 was fine.
Yeah, B1 was fine. So, okay, now B2 says that why do you think the runway should actually be longer than the distance that you've calculated in B1? So the answer to it is basically lies because there are a lot of forces that we haven't accounted for. Do you agree to this statement?
That's lies.
Yeah.
Yeah, okay.
Like, can there be any forces that are acting on a plane? So this is a plane and this moving in this direction, and we've accounted for this force, normal force F, and the force that acts against this the movement, which is T prime.
Oh, yeah.
So in reality, the reason that we'll have to make a longer runway is the reason because there are forces such as air resistance that will be acting on to the plane, which will reduce the value of acceleration even further, and hence we will have to, make the S will grow. The value of S will actually be longer. So is it clear?
Yeah, it's clear.
Okay, so I'm just gonna write because of air resistance.
Mhm.
We need to do this. Now let's come to part C. Okay.
Yeah. Yeah.
So part C says that the plane actually has to move in a horizontal circle. Let me just copy this from the worksheet so that we can also see the. Okay, so Let's just read the question real quick. The jet is used to be flying display in which the pilot will be required to fly the jet in a horizontal circle of radius r at a constant speed 86 meter per second. This is achieved by flying the jet with its wing at 35 degrees to the horizontal. With the jet flying this way, the full forces acting on the jet are the lift L and the weight W, as shown in figure 2.2. So this is L and this is W. Air resistance has negligible effect on the motion of the jet during this maneuver. So we know that there is no there's hardly any other force that's actually working uh, within this because of the air resistance. Now, there's some important thing that we need to highlight, and I think it's already highlighted as well in the question. So I think the examiner kind of gave you the hint of how do you solve this question. So they told you that it's moving in a horizontal circle. Horizontal circle. Now, what does horizontal circle means? What can you imply from this information?
The circle is flat, not flat, but
Okay,
uh,
let me ask you a straightforward question. What do you think the piece of information that the plane is moving in a horizontal circle tell you about the vertical movement of the plane?
that there is no vertical movement.
So there's no vertical movement. So along the y-axis, if I draw, let this be this point be the plane, and this is L, this is W. So along the y-axis, there is no movement. This is the y-axis.
Mm-hmm.
So if I take the y-axis components of L and equate them with W, they should be equal because there is no resultant force actually acting on the plane in the vertical direction so that the plane can move. Is it correct?
Yeah, yeah.
So this is the vertical component that I'm talking about. This should be L cos 35. Okay.
Yeah, okay.
So if there is no vertical movement, then L cos 35 should be equals to the weight of the plane.
Yeah, yeah,
Yeah.
yeah.
And L is the force that we want to find. This is cos 35. Now, what's the weight of the plane? We know that the mass was given in part B. So 6,200 kilograms times 9.81. Let me find my calculator real quick. 200 times 9.81 divided by cos of 35. This gives us the answer 74,250 newtons. So we can approximate this to L to be equals to 74 kilonewtons.
Okay.
Okay, was it
Yeah.
easier?
Yeah, made sense.
Okay. Okay, do you want to try the next part real quick?
Um, okay. Yeah.
So it says you have to find the radius r. Now, I think the last time we had a class, we studied circular motion, where we discussed how the force, where in which in what direction the force is applied, so the object can move in a circle. So I'm just going to give you some time to try this question. If you aren't able to do it, then no problem. We will discuss the question and then we'll solve it together. Okay?
Okay.
I'm
Yeah.
just gonna, all right. Just try part C2.
I got 619.66.
Okay. Is there any way you can share a solution with me so we can say I can like look at the method, or you can just like tell me how you did it, so then I can tell you like if you did it correct or not.
Yep. I used the formula F equals mv squared over r, and then rearranged it for r
Yeah,
with
that's okay. Okay. So, and what was F?
so I used F 74 kilonewtons, which is 74,000 newtons.
Oh, okay. All right. Mm, so you just wrote 74,000 Newton like this, and 6,200 times the speed was 86 squared divided by R. Is that what you did?
Yeah.
Okay, so there's a slight mistake in here when you were plugging F. So we discussed that the force of that causes the circular motion. So if an object is moving in a circle like this, and this is the center, then the force that causes the circular motion is only the force that's acting towards the inner circle. So if we talk about this circle, so the force that causing the circular motion is actually the force that's acting towards the center of the circle. So, okay.
Mm-hmm.
So I will just say this as FC. And can you like see any force or a component of a force which is acting towards the circle, inner circle?
Uh, I'm not sure.
Okay. Let's divide this. Let's draw this again. Okay. So this was W. This was W. This is L, So we found that this is L cos 35. Now there is a component of this force L that's actually being applied to in this direction. Is it?
Yeah.
Yes.
L sine 35. Oh no.
Yes.
Yeah.
So this is L sine 35. So the only force that acting towards the inner circle, towards the center of the circle, is this component of L only. So in place of this, just to remind you that this is the centripetal force, you should always like only plug in the force that is causing the centripetal movement, the circular movement. Sorry. So what you'll do is just make a small change here, which is you'll just say 74,000 Newton times sine 35. So
Okay.
this angle is 35 degrees, and 74,000 Newton times sine 35 is equals to 6,200. The rest is correct. 86 squared divided by R. Just make R the subject and tell me the right answer now.
Okay. Uh, like, so R equals mv squared over F, which is um how do you work out what L sine 35 is? Do you
Okay, the thing is there are only two forces that exist here right now. There's W and there's L. Okay,
yeah.
so and we've already discussed that the L is not the L completely is not the force that's actually causing the circular motion. So the only component of the force L that acts towards the center of the circle. So let me just so this is L. So the only component of the force L that acts towards the center of the circle is the force that's causing the circular motion, because everything else is just used to cancel out weight.
Okay. Yeah.
Okay. Um,
Mm.
so, the is it clear? Is this concept clear, or should I repeat this?
Um. Um.
Oh, all
How
right.
do I? Yeah.
Okay. What we're seeing here is that the circular motion is being caused by a component of L that only acts towards the center of the circle. Now, we've discussed this earlier that if an object moves in a circle like this, the centripetal force acting to move that object in circular motion acts towards the center of the circle. We've already discussed this, right?
Yeah.
So if we're using the formula for the centripetal force to get our value of R, then in place of Fc, we can only use the force that's actually the centripetal force here.
Mm-hmm.
Okay.
Yeah.
So just use this. So centripetal force was L sine 35, and L we found in part one, which was 74,000 Newton times sine 35 is equals to 6,200 times 86 squared divided by R. So just make R the subject and you have your answer. So R is 1,080 meters.
Yeah,
Okay.
I just got that as well. Yeah.
Okay.
So for the force, you only use centripetal force in circles.
Yep. Yeah. So in this formula, F is equals to mv squared divided by R. This is the formula only used, can be only used for the centripetal force. No other force can be plugged in into this.
Okay. Yeah.
Okay, that's is it clear?
Yeah.
Okay. All right, let's move to part C.
Yep.
So mm, at a constant speed of 120 meters per second. Okay, so part C is like a bit easier. Let me just copy this. Let me just ask you one thing. Is the part C different from the? I think, yeah, that's a different question. Let me just.
Okay.
Okay, so I think this question is done till here, and the next question is of a satellite. Is that correct?
Of a satellite. Is there a number on the part C, or does it just say part C?
Um, uh, which question are you talking about?
I don't know which. Can you read the question? I'm not sure which one.
Oh, it's actually the jet plane describes a horizontal circle of radius 870 meters, flying at a constant speed of 120 meters per second.
Yeah, yeah, that is a separate question.
Yeah, that is the question. Okay, so
I think on this question I was only stuck on part D2 with the question mark.
So calculate. All right. By changing it can be made to find a vertical circle of 1500 meters. In the contact force between the pilot and the seat may be zero. Okay. Now that since the plane is moving in a vertical circle, at all the point there's a weight of the plane that's actually working downward. So at this point, so this is I'm just trying to draw the weight of the airplane
Mhm.
at different instances. So at this point, the weights, so at every point if the plane is moving in the vertical circle, let's say this is the plane and it is just flying here like this in a vertical circle.
Yeah.
So at every point, the weight of this circle of this plane is acting downwards. Okay.
Mhm. Yep.
So and the the force that causing it to move, the centripetal force is always towards the center of the circle. So at this point it is this, at this point is this, and let me just tell you, it's always constant.
Okay.
Okay, so let's just consider the plane at this point. Okay,
Mhm.
so the plane was at this point, the weight was actually downwards, and the plane is still moving in the circular motion. So this is the centripetal force that's causing this plane to move in a certain in the circle. Now, if just tell me this, if this centripetal force was to be equals to the weight, can we say that the pilot is gonna experience weightlessness at this point
If it's equal.
if it's equal?
Uh, y- yeah.
Yeah. So just keep this information in mind. Now we need to find the speed v. So the centripetal force is actually equals to mv squared divided by r. And through our deduction through this, can I plug in W in place of this FC because weight is actually equals to the centripetal force?
Oh yeah, yeah.
So I think I just solved this question. So we know the mass of the plane, we need to find V squared, and we know the radius of the circle that it's moving in.
Yeah. Okay.
Okay. So
Yeah.
just use V squared is equals to the weight times R divided by M. We can further simplify this by taking the square root on both sides. So weight times the radius divided by M. This is the solution.
Yeah. Yeah.
Do you get this question?
Yeah. Wait. So you use the weight because it's when it's weightlessness. So one centripetal force is equal to the weight.
Mhm.
Okay. Um,
Hello.
where is the mass given?
Sorry.
Is the mass? I can't find where the mass is given.
I suppose we already know what the mass is. Do we not know the mass?
I'm checking the other question.
I think you've used mass in the part before this.
Oh yeah, mass is given actually. Yeah.
Okay.
Yeah.
Is everything clear?
Yeah.
Okay.
Let's see.
Mm.
I got that answer. 121.3.
Is it clear? Is the solution clear?
Yeah.
All right. So okay, let's just do another question. Have you studied the gravitational force?
9 point. I just know that's 9.81. I haven't done it in detail.
So this question, that of the sat pipe question, it actually uses the concept of the gravitational forces, which is Gmm divided by r square, the gravitational force. Have you seen this formula before?
No.
Okay. So we need to study this topic before we solve this question, so you can actually understand the formulation and everything. Object to okay. Mm,
Should we do a different question then?
yeah, that's what I'm trying to see, because these are like question from a chapter that we haven't actually studied, and you haven't studied it as well. So mm, mm, no, we can't do this as well. So okay, I think that is it. We've done all the questions.
Okay.
So I got 3 questions from your side. Question 1. So the first question we did here was of circular motion, and 2 and 3 are actually of the gravitational forces. So next time you're here, we're gonna study this chapter, and we're gonna discuss this, use this chapter to sort of like learn the formulas and do some questions, so we can actually start doing the past papers. So before we end this class, I was just gonna ask you,
Mm-hmm.
Before this, before we end this class, I just want to ask you, like, can you just share me the list of topics that you've already studied?
Okay. Yeah.
Okay. All right.
Yeah.
So I think this is gonna be it for today. If you have any questions, you can ask me, or
Um, it's about what I would like to study next, because I think in a couple of weeks, like 2 weeks, I have a test on motion.
Mhm.
So chapter, I think it's chapter 3. Yeah, chapter 3. Um, I have a test on that. So if we could go over that, so I think I'll do some, because I've already done it at school, but I just have a test on it coming up. So if
Oh,
I would do some exam questions, and like how we just did now, if I send you the ones I get stuck on, and we could go through that.
yeah, sure, we can, we can. If you want to like study the concept as well, we can do that as well. Since like I have like no idea how well do you know those chapters. So
Mm, yeah.
so this is the, I think, a module of page. So module 3, forces and motion. Is this what you're talking about?
Yeah, that one I've completed it at school, but I just wanted to go over it.
Okay. Okay. So this module I'm seeing has 5 chapters, I suppose. Which
Yeah, it's a
is,
long one, yeah.
yeah, motion. There's forces and work, energy and power, materials, and law of motion and momentum. So it's a pretty big chapter. So would you like to, keep an extra sessions, perhaps over the weekend?
Um, yeah, I'm usually busy on the weekend, so maybe
Okay.
I'll let you know when I'm free. I'll message you.
Okay. Okay. Just drop me a message whenever you're free, and no
Mm-hmm.
problem. We have enough time. We can, go over the chapter. We can study the concept as well, and practice past papers question as well. We can do both of these things so that you're prepared well for the test.
Mm-hmm.
And just if you have any questions in between the week as well, just let me know on like drop me a text on WhatsApp, and probably I can answer that, or just drop me an email so I can tell you the answer.
Okay.
So I think this is gonna be it for today. If you have no other question.
No, that's it.
All right. Okay. So thank you so much for coming today, and
Thank
I
you.
hope to see you. I hope to see you next week. All right.
Yep.
Bye.
Thank you. Bye.